Children, today let us learn an important topic, one of the most important topics of chapter 1. What is that? Stoichiometry and stoichiometric calculations. Now, what is stoichiometry? The word stoichiometry is derived from two Greek words. What are they? Stoichion, which means element, and metron, which means measure. So, what is stoichiometry? It has something to do with elements and measures. So what is it? It deals with the calculation of masses, sometimes volumes also, of the reactants and products involved in a chemical reaction. Okay, so usually we do the numerical calculations related to substances involved in a chemical reaction by taking their masses into account. Okay, we do the usual numerical calculations by taking the masses of substances involved in a chemical reaction. But sometimes when the reactants and products in the chemical reaction are gases, okay, so when the reactants and products are in the form of gases, and if you are asked to do the calculations in terms of volumes, you may have to do so. Okay, so at times you may have to do the numerical problems in terms of volumes. Okay, when your reactants and products are in the form of gases. Okay, so next, calculation of masses and volumes of reactants and products in a chemical reaction is known as stoichiometric calculation. So if somebody asks you what a stoichiometric calculation is, what will be your reply? It means the calculation of masses and volumes of reactants and products, isn't it? Both constitute a chemical reaction. So calculation of masses and volumes of reactants and products in a chemical reaction is known as stoichiometric calculation. Now, let us look at the importance of stoichiometric equations. First of all, what is a stoichiometric equation? It means a balanced chemical equation. What does it mean? Balanced chemical equation. So, balanced chemical equations are otherwise called stoichiometric equations. Now, let us take an example. Okay, here CH4, which means methane, it reacts with oxygen to give carbon dioxide and water. Here methane reacts with oxygen or dioxygen, okay, in order to produce carbon dioxide and water. So carbon dioxide and water are called products, and those substances, chemicals, which react to give these products are called reactants. Okay, now look at the equation. All the reactants and products in this equation are gases. How did you come to know of it? This is denoted by the letter G, which is written within the bracket next to the formula of the chemical substance. Clear? Okay, you write the letter G within the brackets next to the formula of the reactant or product which exists in the form of a gas. Okay, if any of your reactant or product is a solid, how will you represent that? You will write S instead of G near the within the bracket near the chemical formula of the reactant or the product. Now, what if you have liquid as a reactant or product in your chemical equation? How will you represent it? You will write the letter L within the bracket next to the chemical formula of that reactant or product. Clear? Now, one more thing should be discussed here. What is that? You find some numbers, isn't it, in this chemical equation. The number 2 for oxygen on the reactant side and the number 2 for water on the product side are called stoichiometric coefficients. In other words, stoichiometric numbers. Okay, so What about the stoichiometric coefficient for methane on the reactant side and carbon dioxide on the product side? It will be equal to 1. Okay, so what information do you receive from these numbers? They represent the number of molecules, okay, taking part in the reaction as reactants and the number of molecules that are formed as products in the reaction. Now, if you consider the reactants and products involved in this chemical equation as molecules, let's say one molecule of methane undergoes reaction with two molecules of oxygen to produce one molecule of carbon dioxide and two molecules of water. You may also consider this equation in terms of moles. If you consider this equation in terms of moles, how will you represent it? 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of carbon dioxide and 2 moles of water. Clear? So, stoichiometric coefficient tells us either about the number of molecules of reactants and products involved in the chemical reaction, or it tells us about the number of moles of reactants and products involved in a chemical reaction. As I told you in the previous slide, the number of reactants reacting to give products can be represented in any of the following ways. Okay, one molecule of methane reacts with two molecules of oxygen to give one molecule of carbon dioxide and two molecules of water. The same equation may be represented in moles. That is, 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Now, let us learn a new way of representing the same equation. It may be represented in molar mass. How? What is molar mass? You know that the mass of 1 mole of any substance is given by its molar mass. Okay, what is the unit for molar mass? It is grams. So, the mass of 1 mole of any substance is equal to the molar mass of that substance. Okay, it is given in grams. Okay, so we also learnt in previous classes that molar mass of any substance in grams is numerically equal to its atomic mass or molecular mass or formula mass of the substance in unified mass or AMU, as the case may be. Clear? So, what is molar mass? Suppose if 16U is the molecular mass of methane. Methane is a molecule, right? So, if 16U is the molecular mass of methane, then what will be its molar mass? It will be simply 16 grams. Instead of writing U, you write the unit G. Okay, so then it becomes molar mass of methane. Now, look at this equation. Methane plus 2 oxygen gives carbon dioxide plus 2 water. Okay, what is our aim? Our aim is to represent this chemical equation in molar mass. Okay, see, in the last, while I explained the previous slide, I told you how to calculate the molar mass of methane molecule. Okay, here I have just typed it. See, methane, as you know, is a molecule. Its molecular mass can be calculated like there is one atom of carbon, so you multiply it with its atomic mass. What is it? 12U. And there are 4 atoms of hydrogen, so you multiply it with its atomic mass. So you get 4U. So 12U plus 4U, you get 16U. Hence, molar mass. Molar mass is represented in grams. So if you replace U with G, you get the molar mass of methane. which means the mass of 1 mole of methane is 16 grams. Hope you remember what we learned in previous classes. Okay, so how many molecules of methane are there in 16 grams of methane? It contains 6.022 into 10 power 23 molecules of methane, which is 1 mole of methane. Okay, this is just to make you remember of what and all you learned in the previous class about mole concept. Okay, now let us represent this equation in terms of molar mass. How will you represent it? Look at the equation, 16 grams of methane. What is 16 grams? It is the molar mass of methane. It is the mass of 1 mole of methane. So 16 grams of methane reacts with 2 into 16 grams of oxygen. Why do you multiply the molar mass of oxygen with 2? Because there are 2 moles of oxygen here. What is 16 grams? 16 gram is the mass of 1 mole of oxygen. Isn't it? 1 mole of oxygen molecule. Here, since you have 2 moles of oxygen, you write it as 2 into 16 grams of oxygen. Okay, to give 44 grams of carbon dioxide, which is the molar mass of carbon dioxide, and 2 into 18 grams of water. So this is how you represent a chemical equation in molar mass. Now, I told you, you may have to do calculations in terms of volumes if any of your reactants or products are, in the form of gases. Okay, so if the substance is a gas, there is a relation of volume also to the number of moles. Hence, the same equation, okay, may be represented in molar volume. Let's see how we do. Now, what do you mean by molar volume? It is nothing but the volume occupied by 1 mole of any gas. Okay, it is called molar volume. Molar volume of all gases at STP is 22.4 liters. What is STP? It means standard temperature and pressure. At standard temperature and pressure, 1 mole of any gas, be it hydrogen, be it oxygen, okay, 1 mole of any gas occupies 22.4 liters of space. That is, at 273 Kelvin, which is standard temperature, and 1 atmospheric pressure or 760 millimeter mercury, 1 mole of any gas occupies 22.4 liter of space. Okay, now if the reaction methane plus 2 oxygen gives carbon dioxide plus 2 water is taking place at standard temperature and pressure conditions, and if the reactants and products are represented in volume, how will you represent this equation in volume? 22.4 liters of methane. Why? If methane is a gas. Okay. In this equation, all the reactants and products are gases. So what did we learn? We learned 1 mole of any gas occupies 22.4 liters of space at standard temperature and pressure. Okay, here it is given that this equation is taking place at standard temperature and pressure. So here we have 1 mole of methane, 2 moles of oxygen, 1 mole of carbon dioxide and 2 moles of water. Okay, 1 mole of methane gas will then occupy 22.4 liters of space. So that's why we wrote in the while representing the equation, 22.4 liters of methane reacts with 2 into 22.4 liters of oxygen. Why this? Why you are multiplying 22.4 liters with 2? Because molar volume of oxygen is only 22.4 liter, which means 1 mole of oxygen gas occupies 22.4 liters. Here we have 2 moles of oxygen gas. That is why you are multiplying 2 with 22.4 liters. Okay. So in a similar way, you write 22.4 liters of carbon dioxide, and since there are 2 moles of H2O, you write 2 into 22.4 liters of water, H2O gas, or 22.4 liters of methane gas reacts with 44.8 liters of oxygen gas to give 22.4 liters of carbon dioxide gas and 44.8 liters of water vapor. Okay, H2O, water in the form of gas, is called water vapor. Hope you are clear with the way you represent this equation in molar volume. Having learned about all the ways in which an equation can be represented, let us do some calculations based on stoichiometric equations. Okay, let us discuss problem 1.3. It is already solved in your NCERT. Calculate the amount of water. Okay, in bracket you have the letter G, which means water exists in the form of gas, produced by the combustion of 16 grams of methane. So what information do you get from the question? You came to know about one of the products of combustion of methane. What is that? Water. And what is the physical state in which water is existing? It is in gaseous state. Okay. So what is combustion of methane? That's the next question. What is combustion of methane? If a paper burns in air, that is called combustion. And not only paper, if any substance burns in oxygen, it means combustion reaction. And usually the products you get for combustion reaction are carbon dioxide and water. Here, look at the question. Here, what is a reaction? It is the combustion of methane. Methane is burning in air. Okay, so methane reacts with oxygen. So these two will be the reactants, and these will give water vapor on the product side, and the remaining will be carbon dioxide. Now, the next step in solving this problem is balancing of this chemical equation. I will teach you in detail how to balance a chemical equation in the next class. Okay, now we'll just move on with solving the problem. Okay, so if you balanced this chemical equation, you will have methane plus 2 oxygen gives carbon dioxide plus 2 water. Now look at the question. It mentions in particular only about water and methane. There is no information about oxygen or the quantity of oxygen reacted or about the amount of carbon dioxide formed. It talks only about the amount of water and the amount of methane. So there is no need to bother about the calculation of other chemicals involved in the reaction. You need not do any of the calculations of oxygen or carbon dioxide. So as far as this problem is concerned. Okay, now let us consider the reactants and products of the equation in moles. Okay, so 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. Okay, now look at the question. Okay, here you are given the data, numerical data related to methane. What is that? It is in grams. Okay, so what is that? It is the mass of methane in grams, molar mass of methane. How can you do the calculation for molar mass of methane and water? In this way. In methane there are 4 hydrogen atoms and 1 carbon atom. Remember how you calculated molecular mass? Near 12 you wrote U, and near 1 you wrote U. Okay, which means unified mass. But here you can directly write G. Okay, near the atomic mass of carbon, because atomic mass of carbon is numerically equal to its molar mass. Only thing is G, you include G. Instead of U, you include G. Okay, if you solve this, you get 16 grams. In a similar way, you do the calculation of molar mass of water and you get 18 grams as the answer. Children, just to avoid confusion, it is better to write whatever you are asked to find out on the right hand side. Okay, so in the question, what are you asked to find out? You are asked to find out the amount of water produced. So try to write it on the right hand side while you are solving the numerical problem. Okay, so combustion of one, as per the equation or as per the stoichiometric equation you wrote, combustion of 1 mole of methane produces 2 moles of water. And what is 1 mole of methane? It is the mass of 1 mole of methane or molar mass of methane. Okay, molar mass of methane is nothing but the molecular mass of methane. Only thing, instead of U, you write G as unit. Okay, so 16 grams of methane produces 2 moles of water. This is the information you straight away get from your stoichiometric equation. Clear? Okay, so 16 grams of methane produces 2 into 18 grams of water. Why did you multiply? What is this 18 gram? It is the mass of 1 mole of water. In the equation, you find 2 moles of water. So, 1 mole of methane produces 2 moles of water. So, you need to multiply 2 with the molar mass of water. 2 into 18. So, what's the answer? You get 36 grams of water. Clear? Let's solve problem 1.4. Okay. This is different from the first problem we discussed. Okay. Here you are asked to calculate the number of moles of methane. Okay. And you are given the mass, molar mass of carbon dioxide. Okay, so read the question. How many moles of methane are required to produce 22 grams of carbon dioxide gas after combustion? So first step, did you determine the type of reaction going on? It is combustion. Combustion is nothing but any substance burning in oxygen. Here, the reactants will be methane and oxygen. And the usual products of combustion reaction, of any combustion reaction, will be carbon dioxide and water. Okay, after determining the reactants and products, write them as an equation. And then try to balance this chemical equation in order to get the stoichiometric equation. Only after balancing the chemical equation, you can start solving the problem. Clear, or else you will end up with wrong answer. So once you have written the balanced chemical equation, see in the slide I have already written the balanced equation for the combustion of methane. So let us consider the reactants and products of the equation in moles. Okay, so as per the equation, 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water vapor. Okay, so I told you in the previous problem itself, in the question they have mentioned only about methane and carbon dioxide here. So you need not be bothered about the calculations of oxygen and water vapor. You need to do calculations of methane and carbon dioxide alone. You can just leave oxygen and water vapor. You need not take them into consideration. Okay, so as per the chemical equation, okay, 1 mole of carbon dioxide is produced by 1 mole of methane. Remember what I told in the previous slide? I told you, look at the question, you are asked to calculate the number of moles of methane. So whatever you are asked to find out should be written on the right hand side. Okay, hence I have written 1 mole of methane on the right hand side. So look at the equation. 1 mole of carbon dioxide, that is nothing but 44 grams. So 1 mole of carbon dioxide is produced by 1 mole of methane. Okay, 1 mole of carbon dioxide can also be written as 44 grams of carbon dioxide. It is the mass of 1 mole of carbon dioxide. Okay, 44 grams of carbon dioxide is produced by 1 mole of methane. So in order to produce 1 gram of carbon dioxide, okay, how many moles of methane should be burned? It can be written by dividing 1 with 44. Okay, so 22 grams of carbon dioxide would be produced by the following step. You just need to multiply 22 with um, the number which you obtained in the previous step. 1 by 44 into 22 moles of methane. You get 0.5 moles of methane. This is the answer. Children, let us discuss the exercise problem 1.26. If 10 volumes of dihydrogen gas reacts with 5 volumes of dioxygen gas, how many volumes of water vapor would be produced? Okay, so here, first of all, read the question once or twice. Find out the reactants and products. Once you find out the reactants and products, try to write them in a chemical equation. And once you have written the chemical equation, try to balance it. Clear? And after balancing it, usually we consider the reactants and molecules of the stoichiometric or balanced chemical equation in terms of moles. But here in the question itself, they have mentioned volumes. So consider reactants and products of the chemical equation in volumes. Okay, so according to the question, let us solve this problem. The balanced equation. First of all, you should write the equation. You should identify the reactants and products. So it is evidently given in the question itself that the reaction is between hydrogen and oxygen. Dihydrogen is nothing but H2. Okay, and dioxygen is nothing but O2 molecule. So the reactants are hydrogen and oxygen molecules. And what will be the product? The product as given in the question is water vapor. Water vapor is nothing but H2O. Okay, its physical status G, that is gas. It is existing in the gaseous state. Okay, when water exists in the gaseous state, it is called water vapor. So don't get panic when you look at the question. Okay, see, now you need to, once you determine the reactants and products, you need to write them as a chemical equation. So hydrogen plus oxygen gives water. Now you should balance the chemical equation. For balancing the chemical equation, find out which side of the chemical equation bears odd number of atoms. See, oxygen on the product side bears odd number of atoms. That is, there is only one oxygen atom. So you need to make it even. Okay, if you multiply the formula of H2O with 2, it means 2 oxygen atoms. Okay, now look at the reactant side. Already you have 2 oxygen atoms in oxygen molecule. Now as you have written 2 in front of the formula H2O, the number of atoms of hydrogen on the product side will be 4. Now look at the reactant side. There are only 2 hydrogen atoms. So if you write the number 2 just before the chemical formula of hydrogen, you have 4 atoms of hydrogen on the reactant side. So this way you need to write balanced chemical equation for this reaction. Okay, so according to this balanced chemical equation, what is the information you get regarding the volumes of reactants and products involved in the reaction? 2 volumes of hydrogen reacts with 1 volume of oxygen to give 2 volumes of water vapor. Now what is the question? If 10 volumes of hydrogen reacts with 5 volumes of oxygen, what will be the volume of water vapor? Okay, it's just simple arithmetic. Compare the volumes mentioned as per the equation and the compare the volumes mentioned in the slide as per the equation with the volumes that are mentioned as per the question. So all these differ by 5 times, isn't it? So 10 volume and 2 volume, that's the difference of 5 times. Okay, similarly, if you take oxygen, as per the equation it is 1 volume, as per the question it is 5 volumes. So it differs by 5 times. Okay, so in a similar way, as per the equation, there are two volumes of water. So, following the general trend, the volume of water vapor obtained as the product should be 5 times as mentioned in the equation. So it will be equal to 10 volume. Clear? Therefore, volume of water vapor produced by 10 volume of hydrogen and 5 volume of oxygen will be equal to 10 volume. Children, do this problem as homework. Chlorine is prepared in the laboratory by treating manganese dioxide with aqueous hydrochloric acid according to the following reaction. Okay, although this reaction is balanced, it will be better if you try to check whether all atoms are balanced on the reactant and product side, whether the number of atoms are balanced on the reactant and product side. Okay, then you start doing the calculations. Now you need to find out the amount of HCl which will react with 5 grams of manganese dioxide. And another thing, atomic mass of manganese is 55 U. This is not given in your textbook. Okay, so I think you need to memorize this. Now let's learn how to balance chemical equations. But before doing that, let's get to know the theory behind it. Okay, let's get to know the logic behind balancing chemical equations. According to the law of conservation of mass, matter can neither be created nor destroyed. I repeat, matter can neither be created nor destroyed. Clear? So, matter only changes its form. Okay, it is never destroyed. So, therefore, when a chemical reaction takes place, according to the law of conservation of mass, a chemical equation, okay, a chemical equation which you are going to write should have the same number of atoms of each element on both sides of the equation. The number of atoms of each element on the reactant side should be equal to the number of atoms of each element on the product side. Why? Suppose, just imagine you are in a lab and you are performing an experiment involving two reactants. Okay, they both react with each other and result in the formation of, say, 4 products. Okay, although the number of products is more, see, you can find that the number of atoms of each elements of the products in total will be equal to the number of atoms of each element on the reactant side. Now, what does this mean? During a chemical reaction, okay, although the reactants are consumed, they react to form different products. Okay, here matter is not destroyed. It has only changed its form from reactants to products. Okay, so this is the logic behind balancing chemical equations. Okay, during a chemical reaction, I repeat, matter is never destroyed. It only changes its form from reactants to different kinds of products. Okay, at the end, the number of atoms of each element on the reactant side and the product side should be equal. And this is the logic behind balancing chemical equations. Okay, and as you know, you have learned from the last class itself, balanced chemical equations are otherwise called stoichiometric equations. Clear? And we know that if we take a certain amount of reactants, a certain amount of products will be formed. A chemical equation could give us a lot of information about the physical states of the reactants and products. Okay, the conditions of the reactions, like at what temperature and pressure you are carrying out your reaction, what catalyst, if any, you are using in your reaction, and so on. Therefore, just from the fully explained chemical equation, we can plan our reactions as to how much of reactant should we take if this is the amount of product that we intend to obtain. This is just like cooking a cake or baking a cake. Suppose, say if you want to make a 1 kilogram cake, you must measure out each of the ingredients beforehand. Okay, you should have an idea about how much of each ingredient you should add. Okay, in order to get a cake of 1 kilogram with perfect taste. Clear? So in the same way, you should know how much of reactants you should take in order to know the amount of product that you need to obtain. Okay, so this information you will be getting if you balance a chemical equation in the proper way. So how do we balance chemical equations? It's a very simple mathematical process. Any chemical equation can be balanced by trial and error method. But the only thing is that you should take care while writing the formulas of all reactants and products. If you commit any mistake while doing so, you will end up on the wrong side. You will not be able to properly balance a chemical equation because you have done a mistake while writing the formula of reactants and products. So extra care should be taken while writing the formulas of reactants and products in order to get a properly balanced equation. Now, before we move on to balancing of chemical equations, you must know certain things. You must take into consideration all these points while balancing chemical equations. Okay, we cannot change the chemical formula of the reactants and products. Okay, when you are trying to balance the number of atoms of reactants and products, you must not alter, you must not do any change to the chemical formula of the reactants and products. Clear? See, this is an unbalanced chemical equation what I have written here. Okay, here on the product side you can see there are 4 chlorine atoms, isn't it? MnCl2 has 2 chlorine atoms and Cl2 has 2 chlorine atoms. So in total there are 4 chlorine atoms on the product side. Now look at the reactant side. You have only 1 chlorine atom in HCl. What is that? Hydrochloric acid. Okay, so in hydrochloric acid or HCl acid, you have only 1 atom of chlorine in its chemical formula. So if you are trying to balance this, what will you do? You can multiply the entire chemical formula of HCl by a number which you write before the formula of HCl. Okay, instead of that you must not write the number 4 as a subscript of chlorine. If you do that, what would happen to the chemical formula? What would happen to the molecule of HCl? It would be totally different. It will have a totally different meaning. HCl is different from HCl4. Clear? So you cannot do any change to the chemical formula if you are trying to balance the atoms on the reactants and product side. Clear? If you do so, if you change the chemical formula of the reactants and products, then the whole meaning of the equation itself changes. Okay, if you write HCl4, this is totally different compound. If you take HCl, it is different. Hydrochloric acid, this is totally different from HCl4. And let's take another one example. Let us take H2O here. On the product side, there are 2 atoms of hydrogen on the product side. Okay, how will you balance the number of hydrogens on the reactant side? There is only 1 hydrogen atom on the reactant side. So how can you balance the hydrogen atoms? You can write the number 2 in front of the entire formula of HCl. You must not write the number 2 as a subscript of hydrogen. If you do that, what would happen to the chemical formula of HCl? It would become H2Cl, which is a totally different substance when you compare it with HCl alone. Clear? So you should not do any change to the chemical formula of reactants and products in order to balance a chemical equation. Okay. Similarly, subscripts in the formulas of the reactants and products cannot be changed to balance a chemical equation. What do you mean by subscripts? That subscripts are the numbers written below the line. Okay, below the main line. See, if you take MnO2, 2 of O2 is the subscript. See how I have written it? Okay, so you should not do any change to the subscripts, the number of the subscript as written in the chemical equation. MnO2 will remain O2 always. Okay, the MnCl2, the Cl2 in MnCl2 will remain the same always. You should not change it into Cl4 or something like that. If you do that, it will become a totally different substance. Okay. Next point, instead, their formulas can be multiplied by a number or coefficient. As you learnt in your previous class, what is that number? It is stoichiometric coefficient. Okay, so instead, their formulas can be multiplied by a number written before the formula of the reactant or product in order to balance the equation. Same thing I told. Isn't it? If you want to balance a chemical equation, if you want to balance the number of atoms of each element on the reactant and product side, you must not do any change to the chemical formula of the reactants and products. Clear? And you must not do any change to the subscripts written in the formulas. Clear? If you do so, the entire meaning of the substance itself changes. The entire meaning of your chemical equation is changed. Clear? Then it would represent some other chemical equation. It would not represent the equation reaction which you are trying to balance. Okay. Now, these are the points which should be taken into consideration before balancing a chemical equation. So if you want to balance, you can write a number before the entire chemical formula of the reactants and products. The following steps should be followed while balancing a chemical equation. Okay, what are they? First of all, you must write down the correct formulas of the reactants and products. Clear? Second point, if the chemical equation has atoms of elements other than carbon, hydrogen and oxygen, like if you have some other atom of some other element like iron, copper, chromium, xenon, argon, something like that, okay, balance the equation in the following order. First of all, you should balance the element which is present in your equation other than carbon, hydrogen and oxygen. After balancing that elements alone, you must balance the number of carbon atoms. Only after balancing the number of carbon atoms, you should move on to balance the number of hydrogen atoms. You should give last preference to balance the number of oxygen atoms. Clear? This is how you should balance a chemical equation. First of all, if you, as you know, all chemical equations will not have carbon, hydrogen and oxygen alone. They would have different elements too. So you must balance those different elements first. Then you must balance carbon atoms. Then you must balance the number of hydrogen atoms and give last preference to balance oxygen atoms. Clear? If the elements other than carbon, hydrogen and oxygen are already balanced, we can straight away start balancing carbon, hydrogen and oxygen. Okay, so after all these steps, verify that the number of atoms of each element is balanced on the reactant side and products side. So if you strictly adhere to all these steps, you will have a perfectly balanced chemical equation. So let's see how to do this. Now Let us do an exercise problem 1.4. Calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. Okay, here you are given two more situations. You are asked to calculate the amount of carbon dioxide when 1 mole of carbon is burnt in 16 grams of dioxygen. Dioxygen is another way of saying oxygen molecule, O2. The third situation is you are asked to calculate the amount of carbon dioxide when 2 moles of carbon is burnt in 16 grams of oxygen. Okay, now let's solve the first case. First of all, I told you, read the question once or twice. You can see from the question itself the product is carbon dioxide. So on the product side, you can write CO2. Okay, care should be taken in writing the correct formula of reactants and products. Okay, now what are your reactants? 1 mole of carbon is burnt in air. So carbon is burning in air which has oxygen. So carbon is one of the reactants and oxygen O2 is the other reactant. Okay, you cannot write O. Okay, oxygen exists naturally as O2, oxygen molecule. So write O2. Now, having written the reactants and products, you must try to balance the chemical equation. And after balancing, you can see that carbon plus oxygen gives carbon dioxide gas. You need not do further balancing. It is already balanced. There is one carbon atom on the reactant side, one on the product side. Two oxygen atoms on the reactant side and two on the product side. Now, let us try to see this reaction in terms of moles. So 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. Okay. Now, you need not bother about oxygen, that is air. Okay. Here they have not specially mentioned air, the amount of air with which carbon is reacting. So you need not do any calculations about oxygen. Okay, now you need to calculate only the amount of carbon and carbon dioxide. Okay, as per the go with the question, you are asked to calculate the amount of carbon dioxide. So your numerical problem should be centered on carbon dioxide and carbon alone because they have specified the amount of carbon that is burning to give carbon dioxide. So here 1 mole of carbon is burnt. 1 mole of carbon. What do you mean by that? What will be its mass? Okay, it will be equal to 12 grams. See, carbon is an element. Okay, so an atom of carbon is here. So how will you write its molar mass? The atomic mass of carbon is 12U. Okay, I have told you earlier. Okay, atomic mass of any substance is numerically equal to its molar mass. Okay, so molar mass means mass of 1 mole of carbon. Okay, so it will be equal to 12 grams. Next, 32 grams of oxygen. Okay, the molecular mass of oxygen is 32 U, and if you write it in terms of molar mass, replace U with G and you can write 32 grams. Now you know how to calculate the molar mass of carbon dioxide. I don't want to repeat it again here. So 1 mole of carbon, as per the chemical equation, 1 mole of carbon produces 1 mole of carbon dioxide. I told you whatever you are asked to find out should be written on the right hand side in order to avoid confusion. Okay, so what is the question? As per the equation, you have 1 mole of carbon producing 1 mole of carbon dioxide. So they have asked to write the exact amount. Okay, when 1 mole of carbon is burnt. Okay, produced when 1 mole of carbon is burnt. So 1 mole of carbon produces 1 mole of carbon dioxide. If you write it in terms of grams, what is it? It is 44 grams of carbon dioxide. Moving on to the next question, you are asked to find out the amount of carbon dioxide that is produced when 1 mole of carbon reacts with 16 grams of dioxygen. Now, as per the balanced chemical equation, 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide. So, the mass of 1 mole of oxygen here is 32 grams as per the equation, and the mass of 1 mole of carbon dioxide is 44 grams as per the equation, and the mass of 1 mole of carbon is 12 grams. Look at the question. 1 mole of carbon reacts with 16 grams of oxygen. See, so as per the chemical equation, 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. That means if you write moles in terms of grams, you can write in 1 mole of carbon reacts with 32 grams of oxygen to produce 44 grams of carbon dioxide. But as per the question, 1 mole of carbon reacts with 16 grams of oxygen, which is nothing but half mole of oxygen, isn't it? It is half of 1 mole of oxygen. So 1 mole corresponds to 32 grams. So it is half. 16 grams is nothing but half of 32 grams. Okay, so only half the amount of here 1 mole of carbon is reacting with 16 grams of oxygen. So 1 mole of carbon cannot react with half the amount of oxygen. Only half the amount of oxygen can react with half the amount of oxygen, isn't it? Then only half the amount of product would be formed. So half mole of carbon reacts with half mole of oxygen to produce 22 grams of carbon dioxide, which is half the amount of product expected as per the chemical equation. Coming to the last and final part of this question, the third situation. 2 moles of carbon reacts with 16 grams of dioxygen to produce X amounts of carbon dioxide. You are asked to calculate the amount of carbon dioxide that is produced when 2 moles of carbon reacted with 16 grams of dioxygen. As usual, write the chemical equation, balance it. Okay, now express it in terms of moles and write the corresponding molar masses under each reactant and product. Okay, corresponding to 1 mole. Okay, now see, as per the chemical equation, 1 mole of carbon reacts with 1 mole of oxygen to produce 1 mole of carbon dioxide. In other words, we will go ringing along with the question, along with the way the question was asked. 1 mole of carbon reacts with 32 grams of oxygen. See, in the question, they have expressed carbon in moles and they have expressed oxygen in grams. So in the same way, we will also form our sentence. 1 mole of carbon reacts with 32 grams of oxygen to produce 44 grams of carbon dioxide as per the equation. Okay, but as per the question, 2 moles of carbon reacts with 16 grams of oxygen. You are asked to calculate the amount of carbon dioxide produced. Okay, so this means 16 grams of oxygen. What does that sound to you? What meaning do you get from this? See, look at the equation. As per the equation, it is 32 grams of oxygen with which 1 mole of carbon is reacting to produce 1 mole of carbon dioxide. But as per the question, you have 16 grams of oxygen. Only with this amount of oxygen, your carbon is reacting. Okay, so see, 16 is nothing but 32 divided by 2. It is just the half of 32 grams of oxygen. So this corresponds to half mole of oxygen. 32 corresponds to 1 mole of oxygen. So 16 grams of oxygen corresponds to half mole of oxygen. Okay, so as per the question, 2 moles of carbon reacts with 16 grams of, half mole of oxygen. But even if the amount of carbon is doubled, it can react only with half mole of oxygen. Half mole of oxygen in this case. Okay, so only that amount of carbon that can react with 16 grams of oxygen will undergo reaction in this case. So only there is half mole of oxygen. So only half mole of carbon can react with this half mole of oxygen to produce half the amount of product, right? Half mole of oxygen is there. So whatever be the amount of mole that is given in the question, only half mole of carbon can react with half mole of oxygen to give half mole of product. So what will be the uh, value corresponding to half mole of carbon dioxide? It is nothing but half of 44 grams, which is 22 grams of carbon dioxide. So if half mole of carbon reacts with half mole of oxygen, it would produce 22 grams of carbon dioxide. Okay, there is no use even if you increase the amount of reactant. It can only react with the amount of oxygen that is available. Here only half mole of oxygen is available. So there is no use if there is 2 moles of carbon. Only half mole of carbon will react with half mole of oxygen to give half mole of carbon dioxide, which is nothing but half of 44 grams, which is 22 grams of carbon dioxide.